boleh extract ataupun ambil air from the river, take the water from the river. But class 3 means we need to have the extensive treatment. Maknanya air dia agak almost polluted but still okay, but you need to provide extensive or additional treatment in order to make it as a water supply. When I say water supply, means the water can be supplied to the consumer, to the public. Okay. Okay, so far faham for the WQI?
Yeah.
Okay, so that's the purpose for the WQI. So then last week we also have discussed on the 3 parameters, physical, chemical and biological, and we are up until here until apa? Until which parameter? Kau masih ingat last week kita dah sampai mana?
Hardness.
Yes, hardness Okay, thanks Chris. Saya kena tanya, kalau tidak semua senyap je ataupun masing-masing buat benda lain. Okay, so this is the physical parameters. Physical means something that we can sight, kita nampak, we can touch, taste or smell. So the parameter basically on the what? Total solids. This semester you are not taking environmental lab? Dah buat ke belum? Ke next semester?
Next semester.
Next semester. So in the lab, actually one of the parameter that you are going to test is a total solid. Okay, by using this one. For example, let's say you need to identify, differentiate between the dissolved solid and also the suspended solid. Suspended yang terampai lah, yang tersekat di apa nama ni, filter paper. Tapi yang jadi dissolved ni unknown so we need to do checking lah, testing. Okay, what inside is it having the very high calcium, chloride, nitrates, phosphorus and other parameters. Okay, sebab dia jadi air dissolve. Okay, turbidity we know that it is kekeruhan the cloudiness of the water. Okay, I already discussed. And then pH, I think everybody knows. Okay, we must having the good pH which is neutral, so that the water we can use for our potable uses. Okay. Alright, and then hardness. Okay, today I will continue with hardness. Okay, and then after this I will take a break to provide you a quiz for chapter 3. Yeah, A and ENP. Online saja. So before that, can anyone explain to me what does it mean by hardness? Respond. Volunteer first.
The total concentration of cations.
Total concentration of cations lembut-lembut in the water. Ya, betul Lee. Okay. So why do we need to measure hardness? Ada siapa nak cuba? Loshini ada?
Sini lain ada masalah doktor.
Ada masalah? Okay. Muhammad Iqmal. Muhammad Iqmal ada?
Ada doktor, ada.
So why do we need to measure hardness? Kenapa kena test hardness?
Sebab kita nak tentukan dia boleh resist deformation ke tak.
Dia resist apa?
Deformation.
Doktor, kalau nak tentukan kualiti,
Kualiti apa? Nak tentukan kualiti, okay, water quality. Sekarang ni yang saya tanya, kenapa kita nak measure hardness? Apa Ridwan? Tujuan dia apa? What's the purpose?
Untuk tahu dia punya strength.
Strength, okay. Ridwan nak cakap apa?
keterimaan komponen.
Keterimaan komponen. Okey, ada lagi nak cuba? It's a good try Adalah
To know the side effect.
to make the what?
To know the side effect.
The side effect, okay. Alright, I think everyone's have a basic understanding of why do we need to measure hardness. Okay, so from these photos that I show you in the slide, what you can see here, the formations of what? Ini dekat mana ni? Dekat you punya shower, right? You shower and then this is the part. What's happening actually? Cepat sikit. Anyone?
Carbonate calcium.
Yes, calcium carbonate form, right? And it actually develop the scaling. Ada scaling, right? Scaling in this, like the, what we call this? Appliances and water appliances, right? Pipes. This is from the shower and this one from, what is this? Ini?
I think this is heater or
Okay. Due to this cation, actually there are many cations, but the dominant ion is calcium and magnesium that cause hardness.
Wow.
Okay. Besides the scaling, it also can give difficulty for cleaning. If you want to clean your or washing your clothes, it doesn't effective. Tak berkesan. So, okay, faham Okay. Ini submit Okay, that's why we need to measure the hardness. Okay, the problem in the, if happens at house, still okay. That means you can change this head of the shower, right? But imagine if it is happens in the industry, in the factory, big industry. Kan? So that means it can cause a lot of the maintenance issue. Big budget needed to remove this one or replace these appliances. For instance, this is one of my project in the industry where the water they use is a RO, but still having this, I mean, they can ions lah that can cause or develop the scale. So this is a very big issue in the industry actually. Okay, this is the forms of the carbonate hardness. Why carbonate? Sometimes you will wondering, right? Why carbonate hardness? Because usually for the carbon, there are many ions available in the water. Okay, besides calcium or magnesium, they have fluorides, they have sulfates. So we take these two major components as our measurement for hardness, and when they react with the calcium carbonate, this one, so they will form this calcium bicarbonate like this, and also the magnesium bicarbonate like this. Okay, they will interact with the bicarbonate and also the carbonate to form these compounds. So this will be our measurements of this. We call it as a carbonate hardness. Yeah. Okay, another one is a non-carbonate hardness, which means that this is very difficult to remove, right? Because they are combined with the non-carbonate, which means the compound is chloride, sulfate and nitrate. So this one, they need to have extra additional treatment, which means they need to add some soda ash or sodium carbonate to remove this kind of non-carbonate hardness. Sometimes they call it also permanent hardness. They're very difficult to remove, yeah. So maybe you keep wondering, why is this, the elements are available in the water? So basically, this calcium and magnesium and also the other ions, mostly cations, they are comes from the geology. Sekejap salah ni. Geological factor. Daripada tanah from the soil. So depends. If the soil types in that area got lots of these elements or metals because of the mining area, so it can cause lots of this issue on the harness. Tengok kawasan tu lah. Okay. So this is the formula on how you can calculate the total harness, right? Okay, and then this is the example. But today I would like to share with you, I already discussed, another example, but before that I would like to explain on the alkalinity. Alkalinity, Okay, so alkalinity is actually the measurement on buffering. That means we need to calculate the alkalinity so that we know the ability of the water to neutralize acid. Okay, so alkalinity is the buffer capacity, and then usually we refer to is either hydroxide ions or carbonate ions. Okay, maybe susah nak faham kan? Okay, do you have soda bicarbonate at home or baking powder? Now we are in the Eid festive, right? Everyone's now we already second week, another 2 weeks to go before the Eid or Raya. So maybe some of you already start baking a cake, biscuits, cookies and everything. Pakai tak soda bicarbonate? Do you use soda bicarbonate?
Yes, doctor.
Yeah.
Do you know the functions of soda bicarbonate? Soda bicarbonate.
No,
Yes.
doktor.
Betul. It's actually a
Makan je.
source of alkaline. Kan dia rasa pahit kan?
Yeah.
Sebab the role is to neutralize the acids so that it can produce CO2. Bila CO2 dia akan kembang lah kek tu. Ada CO2, dia akan kembang. Tu function dia, to neutralize acid. Dia akan prevent acid, bagi some sort of the alkaline taste ataupun neutralkan lah acid. Dia rasa pahit. Okay, beside baking, actually soda bicarbonate has lots of functions. Siapa pernah guna for cleaning? Untuk remove some, what you call that? Cleaning lah. Also,
Pernah.
ada dia punya resipi, saya lupa. Then, if you want to remove bad odors in the refrigerator, you can also put satu bekas lah soda bicarbonate. Boleh juga. So they have actually many roles or function of this soda bicarbonate. Is like a salt. Dia ialah sejenis garam. Tapi it can neutralize the acid. Okay. Okay, for the health benefits for human being, manusia, kan sometimes during the fasting month we got this gastric kan because of the acid banyak kan? Betul? We also can use soda bicarbonate to neutralize the acid in our body. Boleh juga. So ada banyak function sebab fungsi dia ialah to neutralize acid. So in the water also this alkalinity is very important. So we can measure in terms of carbonate ions or bicarbonate. HCO3 ni ada function ni. So ni akan menyebabkan dia alkaline. Okay. Lagi apa banyak function. It can be used also to whitening your teeth. Pernah dengar tak? Gosok sedikit dengan soda bicarbonate can make your teeth whiten. Boleh cubalah.
Pernah.
Pernah
Apa
juga.
doktor? Apa doktor? Wonton?
Whitening, teeth whitening.
Oh,
Whitening. Nak raya ni bolehlah cuba, tapi tengoklah resipi dia dekat Google. Masa gosok gigi tu letak sedikit soda bicarbonate. You can put some soda bicarbonate after for cleaning your teeth. Dia jadi putih. So I'm sharing you with this one because it's related to this alkalinity lah. Okay, in the water, we must know how much is the alkalinity so that we know the ability of the water to resist the acid. Because acid too sometimes not good in the water because it is when the acid is too much in the water, it can apa maksudnya, in the pipelines it can it can also make or absorb the lead, zinc or copper in the pipelines. That's one of the what we call the harmful effects of high acidity of water. Okay, get it? Boleh faham? That's why we need to have neutral water ataupun the water must be neutral around 6 to 9 ataupun 6.5 to 8.5 so that indicates the healthiness of the water. If low pH, it can corrosion. Is it corrosion? Apa nama dia? Saya lupa lah dia punya terms dia. But it can also absorb some of from the pipelines, the copper, lead dengan zinc from the pipe. So that from the pipe tu kan, it can what we call that, insert in the water. Jadi tak bagus lah bila banyak metals being corroded from the pipe. Okay, boleh. Tapi dia punya calculation dia ada kaitan dengan hardness. Okay, ini boleh baca sendiri because this one is how we can refer to calcium carbonate. Semuanya refer to calcium carbonate. Why? Because this is dominant dominant ion Jadi because in the water there are lots of the cations, right? Sulfate, so dia ada macam-macam lah. So to easy for the researchers or scientists to do the measurement, they just refer to calcium carbonate. Okay. In here, that means dia kata in the river system, okay, this is in the river kan macam ni kan. Usually they have this limestone bedrock. Okay, in the river they have this bedrock. Okay, the bedrock is actually eroded and it produce the calcium carbonate in the water. So this one, if we have lots of this bedrock, that means if the water have certain pollution kat sini with low pH, so the bedrock can neutralize the pH. But must be within the values, for example 20 to 200 ppm. That's the common concentration in the good ecosystem of fresh water. Kalau dia rendah sangat, maknanya indicates the poorly buffer system. So actually the bedrock is very important to maintain the river water quality because it can provide the calcium carbonate, which means can give like resist to any pH or apa namanya pH that what we call that, insert into the water system. Macam ni kan, dia ada pollution that dispose of in the water system. So yang ni kalau ada banyak bedrock, that means it can resist the changes so that the water is healthy. Boleh faham? Maaf yang ni lisan tak nampak. Eraser sikit, ni sebenarnya low pH. pH lower ni sometimes because of the pollution ya. Hilang. Due to the pollution. Mana ni? Lower pH ya. So lower pH can go to maybe 3 to 5, something like that. So this is indicates the poor pH acid ya. So here we have this bedrock. Bedrock ni sometimes yelah bila river water running, they have a rock kan, dekat sini. So kita kena maintain. Okay, faham. Boleh faham semua? Any question for alkalinity, hardness and alkalinity?
Okay lah doktor.
Boleh So saya repeat balik. Kalau hardness tadi, the hardness is actually we want to measure so that the water, how much is the level of the calcium and magnesium, right? The cation. This is the dominant. Actually in the water system there are lots of the cation, but this one is our reference to calculate the total hardness. Okay, why we need to measure the total hardness? Because in the industry, for example, because for the larger scale industry, we need to avoid this one, scaling. Okay, beside industry, at our home also, it can produce lots of issue on the scaling, and in terms of the taste also, and also it's not efficient for washing. You want to wash your clothes, you want to do all the cleaning, it doesn't effective if the water is too high in hardness. Boleh faham Okay, besides the total hardness, then we also need to measure the alkalinity. This is the ability of the water to resist the pH, the low pH. If the water is too acidic, then the good levels of alkalinity can resist the pH changes. So the water is healthy, the healthiness of the water. So the one that contribute to the alkalinity are the levels of bicarbonates in the water. Buffering masih ada bicarbonate ataupun carbonate ions, because it can produce the CO2. So the water becomes a little bit bitter because of the levels of the carbon dioxide in the water. Okay, so minus H plus because it resists the pH changes, so that the water become neutralized to the low pH Okay, in the river system, from the limestone it can produce the calcium carbonate, which means that this one is very good ability to resist any pH changes. For example, if the water got some pollution enter, okay, the water is too acidic, it can neutralize the water. So the water is still okay, still good to be used as our water supply. Okay, so this one also we want to prevent the fault pipes. Okay, because it can resulting in the what we call this tadi saya kata extracting the metals from this, extracting the metals from the pipes for example is zinc, lead and also copper, which is if these metals are extracting from the pipes, it becomes available in the water. So we as a public can consume this one. It's very high. It can give some effect to the health. Macam tu. Harap semua faham. Tak faham boleh tanya lagi Okay, then how to calculate the total hardness, carbonate hardness, non-carbonate hardness, alkalinity, and how you can construct a bar chart by using this example. Okay, in the water having pH 7.2, okay, looks fine because this is still in the range of neutral. So in the water sample we check the calcium 40 mg per liter, magnesium, so all of these are metals and elements already checked, test, but we need to calculate how much is the total hardness. Is it very high, medium or low? We need to know the levels. Okay, how about the alkalinity? Is it a good buffering system available in the water or no? Okay, so how? So first we need to construct this table, easy for us. So we listed everything, okay, given the ion given, calcium, magnesium, sodium, potassium. Ni kalau siapa yang lupa nama-nama biasa, general or common names. This one is bicarbonate, sulfate and chloride. Boleh faham? Okay, this one given from the question. That means the lab already tested and this is the result or concentration for each of the ion. Okay, what is the MW? What is the MW? Anyone? Last week ni ada juga saya terangkan. Last week I already mentioned a bit and discuss about the calculation. MW ni apa?
Molecular weight.
Yes, correct. Molecular weight. From where we get this molecular weight? Ada yang masih lagi tak faham ke dan sebagainya? Nizozen. Okay, saya sebut.
Ya, doktor.
From where we get this molecular weight?
From the periodic table we can get.
Yes. Betul From the periodic table. Okay. N ni apa maksudnya apa? N.
Cation.
Dia punya ion ataupun valence. Alright. So first of all, we need to calculate the equivalent weight. Weight ni ialah equivalent weight. Kalau dalam in the previous slide, I put as a EW. Sama je. EW. Sama EW maknanya equivalent weight. Okay, how to calculate the equivalent weight is macam mana? Muhammad Syukri. Macam mana nak dapat 20.05 ni? Muhammad Syukri bin Jalal. Tak ada?
Ya, doktor.
How to calculate the equivalent weight? Wait, alien. Lain tak okey ke apa? Tak ada. Nur Adila, macam nak kira ni?
Bahagi, doktor.
Bahagi apa? Apa yang bagi? 3. Maknanya?
Berapa dengan N tu.
Okay. So, molecular weight bagikan dengan N. Maknanya 40.1 divided by 2. So, you can get this one. Right? Okay. Then, this one. 2 dengan 5. Okay, ada macam cara you can also calculate this concentration divide by 5 then divide and then kena darabkan dengan 5 sebab apa? Ni kalsium karbonat ni. Ni kena ini ialah 50. Kita punya reference our reference. Okay, how to calculate this Y50 because you calculate lah dia punya molecular weight dia 40 plus kalau calcium berapa? Molecular weight for calcium? Calcium pula. Sorry. Carbon. 12 kan? Campurkan dengan Kalau oxygen how much is the molecular weight in the periodic table?
16.
16 ya, 16 times 3. So berapa ni? Ni saya nak terangkan ni lah macam mana dapat 50 je. So ini ialah 100. Alamak. Apa punya 100 saya ni? Boleh lah 100. So balance dia kalau calcium carbonate dia ada reaction dia So 2 plus. So 100 divide by 2 50. Ni sebabkan dia punya overall charge during the reaction is 2 plus. So we got 50. That's why we times with 50 kat sini. So yang the rest is sama saja proses dia. Then you can calculate. Kalau untuk hardness, you must refer to calcium and magnesium only. Yang lain tak payah. Dia kena buat. Kalau tak buat, dia tak faham. Jadi saya ada sediakan previous question punya ni. Try dulu. Ni. Example of the question for tutorial for today. Nampak tak? So this one, sample of water has been tested and the concentration given. Calcium 150, magnesium 60, bicarbonate 39, carbonate 24.5, pH 12. So you need to calculate the total hardness. First, buatlah macam ni. You can create your table, then try to calculate. Macam ni. So this is the what we call the molecular weight or atomic weight. Molecular weight sebab dia ada dua compound. Kalau one is atomic weight, so tak apalah kita panggil sebagai molecular weight. Try dulu, nanti kita buat sama-sama. Masukkan dalam table ni. Lepas ni saya akan tanya. Dalam masa 5 minit ya. 5 minutes only. It's just exercise in order for you to familiarize on how to calculate the hardness. Hardness for individual. But for the total hardness, macam mana kita nak kira? Siap? Okey. Okey Boleh kita mulakan? Okey. First, for the calcium, concentration is 150, atomic weight given from the periodic table, balance is 2, charge ni 2 kan. So how much is the equivalent weight? Tenang je ni.
20.
Yes, semua ayat correct ya. So 40 divided by 2 is 20. So how much is the hardness? Tilaka. How much you get for the hardness for calcium? Tilaka.
Yes, doctor.
How much do you get for calcium, ion calcium, the hardness, individual hardness sekarang kita kira. How much?
150 plus the 20, 170 doctor.
150
Plus 20.
plus 20 plus 20. Ya ke? So berapa total dia? Dah kira belum?
I got under 70. I plus it under 50 plus it 20 the equivalent weight.
So your hardness has how much?
Under 70.
170.
I think
170. Yang lain? Okay, good try. Nanti tengok balik what actually the correct answer Tilaka.
okay doctor.
Yang lain dapat berapa? Teh Heng Yu. Huh? 100. Berapa dia dapat? Tak dengar. 100 Hardness for the calcium only. Nanti you kena tengok balik. Siti Zulaika. Jawapan dia berapa? Sebelum saya bagi dia punya jalan kerja. Siti Zulaika tak ada? Yes, Lim. That's the correct answer. Thank you, Lim. Okay lah, tak apalah, lambat so kita kira lah 150 times weight 50 divide by 20. Ini ialah equivalent weight for calcium carbonate, and this one equivalent weight for calcium and then we can get 375. Boleh semua? That's how we calculate the hardness for calcium. So try for magnesium. Saya dah bagi contoh dah ni kat atas. Easy, right? So ini berapa? Muayyad, how much this one? Equivalent weight for magnesium.
12
Yes. 12.15.
15.
No.
15.
So 24.3 divided by 2 means, wait, what's happening here? 12.2 lah. Okay, this one how much? Apa yang bagi jawapan kat sini? Sekejap, tak nampak. 246.9 betul. Okay, dah bagi jawapan je lah So dia punya solution is same with the calcium. So 246.6.
246.9. No, it is 245.9.
Okay, that's okay. Almost. Boleh lah halal. Okay, for the bicarbonate how much is the equivalent weight?
61.
Yes, because the balance is 1, so 61. So this one,
This one,
39 times with what? 50 divided by 61. So how much?
76.2.
Huh?
76.2.
You sure? Yang lain? Check again.
31.97.
Yes, saya ambil 32 je lah. 32 Okay. Then carbonate, how much? This one 30 and this one 24. 8.5, 24.5 times 50 because equivalent weight for calcium carbonate divide by 30. So how much?
Forty-one.
Yes, 41 Okay. Alright, for the pH, okay, ni susah, bukan susah lah. You need to carefully understand. Given pH is 12, right? 12, not milligram per liter, but you need to change the concentration to milligram per liter here. So this one negative 7 kita salah ni. 1 times 10 power by negative 7. So how you calculate from the pH 12, convert to pH, the ion hydrogen to get this one, the concentration in milligram per liter. So you need to refer to our slide here on pH. Okay, example of the calculation is like this. pH of 10 on how you can calculate and convert to milligram per liter. Macam ni. Okay, so you need to interlock this one, then you can get the concentration in milligram per liter. Macam ni. This is the example, yeah. Okay, then for our tutorial like this, first you need to calculate this one. Does anyone know how to calculate? From the pH, then you need to convert to milligram per liter as ion hydrogen. Ada siapa dah buat? Senang je kan? Macam ni lah. Saya tunjukkan terus. Okay. So pH bukannya 10, 12 kan? Soalan ni apa tadi? Saya pun silap ni. So maknanya dekat sini ialah 12 ya? Betul 12? 12, not 10. 12 ya? So how much is the H plus here? Sekejap 10 ke 12? Saya pun dah confused. 12 right? 12. So how much is it? Still 1 times 10 power by negative 7? Tu ke ni? So I want you to check.
Negative 9.
Yeah?
1 times 10, negative 9.
Negative 9 Yang lain dapat tak negative 9?
Power of negative 9.
Power of negative 9, not 7, right?
I think. I'm not sure.
Buat. Saya tak ubah lagi tu. Ci dapat? Ci yang kai?
Tak dapat.
Tak dapat ini. Kena tekan calculator ni.
Sekejap saya tekan lagi.
Muhammad Abkori. Yang berapa? Abkori bin
Saya pun dapat negatif 9.
negatif 9. Saya rasa pun betul lah negatif 9. Okay. So yang bawah ni kalau tadi I mean for pH we know that pH is 14. Kalau dekat sini 12, kat sini mesti berapa? 2 You must put in here 2 because pH the total is 14. So when we have this take this 12, then the rest another 2 is for iron hydroxide. Why 17? Because oxygen is 16, hydrogen is 1, so must got 17 in here. This one is conversion, conversion. So how much is the OH negative here? Tolong kirakan. Nurliana dapat berapa? Nurliana Aida. 170. 170 Yang lain dapat? Ini betul. Cuma 70 juga. One seven zero. Betul 170. For the hydroxide. Betul? Milligram per liter. One seven zero. Okay. Jadi dekat sini ialah berapa tadi lupa dah. 9 kan? Yang ini 170 betul? Okey, ini bagaimana kita menjadi weight? Tambah lagi kan? 1. Dan yang ini 70 betul? Okey, ini berapa? How much? Ini cuba cuba dulu. Berapa nilainya? Ya. Yang sampai nak jawab. Bantu saya ya.
Will be a 5 times.
Type please. Ayat 5 10 negatif 8. Walaupun dua semester sama tak ada titik. Sorry ya. Anda pakai cuba. Apa ini dia? Tahu sama sikit. 5 times 10 negatif 48. Correct? Did you get this also, Ayat? Alright. Then finally, kita talk the hydroxide ion 170 times 50 as calcium carbonate yang punya divide by 17. Kita dapat so how much? 500 400 okay. 400. Okay. Then we complete the table, which is good. And then we calculate the total hardness. The total hardness refer to only ion calcium and magnesium. You must ask why doctor only calcium and magnesium? Because these two ions are the dominant of the cation available in the water. So we must just refer to calcium and magnesium to represent all the cations. Faham? Boleh? So carilah apa calcium and magnesium. 375 plus 246.9. So calculate like 375 plus 246.9. Okay. So how much? Berapa? 621.9 milligram calcium carbonate. Okay? Okay, betul lah Jasmine Okay. So you must wondering so this station 621.9 is it very high levels of hardness, moderate or low? So you can check in here in our slide in the sections of hardness dan kat sini ada level kan ni. So that means what? The water is apa dia? The water is
Very high.
yes, very hard. I mean, as a water operator, this is like a headache. You need to solve it. But nanti, if the water supply to the industry, for example, for the house also, it can cause a lot of issues. Even the sustaining, you cannot do your washing and cleaning, difficult to do your washing, and so on. It can also cause lots of these costs to replace your shower, for example, the scaling of your pipelines and everything. So this one is need to avoid. Okay. Okay, apa tadi? Okay. Okay, how to calculate the activity? You can check here. Activity means you need to consider the carbonate. Okay, this is the formula carbonate, bicarbonate, plus pH plus, negative, minus pH plus. So yang ni, kalau ni, carbonate 41 is it correct? 41? Bicarbonate itu betul. Is it correct? OH negative 500 kan? From the table, from our table, 500 betul. This one, with 8, betul. Bukan tak. Betul lah. So how much is the alkalinity now? Kira-kira. 41 ni from the carbonate, betul. Sekejap. Betul lah, 41. Bicarbonate 32. Okay, kan calculator. Yana 5. Betul. 573 yang lain dapat. Yang Yana 5 okay. 573 betul lah. 573. Okay. Why we need to measure alkalinity? Recap balik. bila kita dapat ni, mana lah. Is it the concentration is high ke, okay, good ke, acceptable ke, macam mana? Right. Haris Dahlan. How to check the alkalinity level ni? Is it very high, low or moderate? Haris ada. Isyamuddin. Yeah, very high. Alkalinity very high. Okay, kita kedua ke alkalinity. Alkalinity. Yeah. So you can check here the information on alkalinity. 220 to 200 are common, so that means if the number is exceeds to 200, so it's not a good buffering system. Whether it is too high of the alkalinity, also not good. It must be within the range of this one, 220 to 200. Ini baguslah. Kalau ni drop sikit sangat, tapi kalau terlalu banyak this is exceed, then also not good. So must be within this range. So the alkalinity means the ability of the water to resist any pH changes, because we want also to make sure that the water is neutral, okay, so that it can cause any, for example, the fault of pipes, because it can extract certain metals from the pipe into the water, which means if the concentration is very high in the water system, it can also give detrimental effects to the health, human health. Kalau siapa yang berikan kat rumah, anyone having an aquarium fish, biasanya you need to check that level. Ada? Aquarium. Nampak je. Macam dia jawapan. Ada ya? Siapa Ada. So anyone who has pemeliharaan, you have the aquarium in the house, you need to always check your alkalinity level to make sure that the pH is good for the fish to survive, to live. Okay. Then actually the one that I showed you before is the tutorial that we did together. Same what this one. Macam cara dia tidak macam apa namanya? Slightly different, but sama-sama dia sebenarnya. Okay, so this is the sensor calculation you can refer, right? And then this is the equation. Sekejap ya. Equation to calculate the alkalinity. Again, the alkalinity. Dia tanya ni. Faham ke tidak korang ni? Dia orang lain. Kevin ada? Ada. Okay, the functions of alkalinity. Boleh type juga ya. Analyze. What? Ability of ion in water?
The red to the rice hydrogen ion.
Okay, boleh baca dekat slide, right? But you need to understand apa sebenarnya yang berlaku yang saya pernah bagi example. Okay, so the ability of the water to resist any pH changes. So in order to maintain the water neutrality, kena neutral most of the time must be neutral. Kalau tidak ada banyak-banyak alam. Alright, this is the formula you can check. We already did some exercise before. You can also Actually, I put the tutorial in the portal. Siapa yang perasan? Malah tak. Actually, I put the tutorial for next exercise. We can discuss next week during the lecture. So please try the tutorial to calculate the hardness and the calamity, and also the rest for the theoretical Kahneman and the OD. You can go to the slide. Boleh Senyap maknanya setuju lah. Okay.
Setuju.
Senyap je. Lagi satu.
Doktor.
Ya.
Tadi saya tengok dekat author tak jumpa itu tutorial.
Tak jumpa
Tak jumpa.
Saya tak share ke? Saya check lagi. Thank you. Beritahu. Okay, one more thing. Actually, we can construct this bar chart for the total hardness, the vapor concentration. We can compile it like this. Okay, based on our result, we can do this. Sebenarnya, the concentration for the cation and ion must be same. Sama sebenarnya. And this one, because we know that the total hardness is the sum of calcium and magnesium, so the total hardness is here. Okay, this is the carbonate hardness. Carbonate hardness is come from the either the bicarbonate, and non-carbonate hardness is something that we can sum up from the sulfate. Macam ni, 1:1. Dia punya idea macam ni. Non-carbonate hardness, that means total hardness minus bicarbonate hardness, we can get 50.9. 50.9. Okay. Soalan takkan ni.
Tak.
So you can try the tutorial for exercise. I will check in author. It's either I did not share or what. Okay, can I give you the second quiz for EIEMP?
Sure.
Okay, online je.
Dekat assessment atau
Satu dekat assessment. Boleh masukkan ni sekejap. Oh, yang tutorial not assessment. Tutorial is individual activity. Saya letak dulu, check balik my Google Form, and I will let you know. Kita break je. Okay, dah ada. Tutorial. Kita tak share, sorry. So now you can get your tutorial number 1, your quality in the individual activity. So this tutorial, you can try, do the exercise, and then you will submit in the portal for my record. No marking, just exercise. That means next week we will discuss together. It's better for you to try first, yeah? Boleh?
Okay, doktor.
That's good. Now is the assessment. Masukkan ke assessment lah. Quiz number 2. Quiz number 2.
susah nak kata.
Susah. Salah, senang je. Yang lain Okay. Nak masukkan. Belum. Okay. Okay, animation. Aku nak belajar. Sorry. Sekarang. Dapat tak? Dia nak alter. Boleh saya share dekat sini So you can start now until 3:20. You can start your quiz now, yeah? 3 minutes more. Okay, another 1 minute. Please submit your answer. Please submit now, ya. Dah 3:20. Okay, done. Done, ya. Okay, then I can discuss with all of you the answer for the quiz number 2.
Doktor, tadi saya submit tapi dia tulis situ dah no longer accept.
Sebab dah lambat. Lagi siapa tak submit? Sekejap. Boleh submit sekarang lah. 1 minit, ya. Masa kecederaan 1 minit. So 1 minit ni saya bagi peluang pada siapa yang tak dapat submit tadi. Last, before I off. Okay, dah?
Terima kasih doktor.
Okay, dah. Dah, So kalau ada quiz lagi, tak ada lagi lah kecederaan semua Kena ikut betul-betul the allocate time that given. Tapi saya akan release score. Okay. Tapi saya kena check because your class is 50 but the response 54. How come? Ada double ke apa ni? Apa yang hantar 2 kali ni? Ya. Kita berapa orang? 50 ke 55? Okay. So first question, okay, most of you the answer correctly about the introduced since when? 1988 jawapannya betul Alright. Aim of the undertaking IA for the project is to minimize the MRT impact which can achieve by the EIA. So that means all answers are correct. So mostly answer okay, 53, only one no. 2 types of EIA procedure for physical activity, the first schedule and second schedule, all given the correct answer, that's good. Physical activities fall under first schedule require both public display and public comment. Betul, no only 4 said yes, you need to revise ni, siapa yang jawab. In public display and also public comment only for second schedule not first schedule. Okay. Roles and responsibility of IA including departments of environment, air consultant and public. If all of you said yes to all of this answer then correct. 51. Ada 2 yang jawab numbers yang ni only and also 1 for public. Means kena study lagi lah. Siapa yang tak jawab tu Below are preparations guideline for pre-EIA submission stage except and number 1 So 50 said okay if you are answer the first one. The rest is no. During submissions of the second scheduled EIA report, 50 copies of EIA must be submitted to the DOE, 5 copies to the DOE HQ and 45 copies distributed by the project initiator. Is it correct? The answer is yes. 47 said yes, okay. 7 said no. Macam balik ni. The key aspect during the TOR, terms of reference process in IA is to identify all possible environmental effects. Jawapannya ialah no. Ada yang kurang ni. One of the principles of EMP is to ensure proper implementation of all environmental consideration recommended in the EIA report. Betul ke ni? Betul lah kan? So mostly say yes. Below are the important components required in preparing the EMP except specification and format. Betul lah. TOR ni bukan setakat identify all possible environmental impact tapi ada juga lain komponen Okay. So I can release the results. Next time kena guna UTaship email Okay, that one is for the quiz number 2. So well done lah. Yang not perform, you need to do some revision for this chapter 3. Read again. Okay, to enhance your understanding. Boleh? Okay, saya nak pergi toilet kejap. Boleh sekejap lah. Take a break for 2 or 3 minutes before we proceed with the rest of the chapter. Sekejap, kita akan continue with this one. Boleh Jadi saya datang.
Okay, doktor.
Okay, shall we continue?
Yes, doktor.
Okay. Okay, next is about the theoretical oxygen demand in the water. So basically in the water, one of the requirement to know the levels of the water quality is oxygen demand. It's not only us as a human being needs oxygen, okay, as our daily requirement for us to survive, but in the water also, because we do have the microorganisms in order for them to healthiness of the water or ecosystem, to run the ecosystem. Okay, so oxygen demand is very important indicator for BOD measurement, chemical oxygen demand, and also nitrogenous oxygen demand. Okay, so this is basically we must know the how much is the oxygen in the water. Very important, yeah. So what does it mean by theoretical oxygen demand? So this is actually the amount of oxygen required to oxidize a substance to carbon dioxide and water. So basically, in the water, we have lots of the substance, right? For example, the carbohydrate. We have also protein. We have lipid. Lipid ni minyak oil. Protein, lipid, and very complex substance in the water. Comes from various sources. For example, if we have food waste, from the plants, okay, from the animals, and so on. So this kind of the substance actually contribute to the what we call it, the amounts are needed for the oxygen demand. Why? Okay, this is the stoichiometry of the chemical composition of the substance. Theoretical oxygen demand of X like this. Okay, the compound or substance you want to measure. So from there, you can calculate the oxygen required in the water. MW means molecular weight. Okay, glucose. Glucose ni apa? Gula Can be found from the food, for example. Glucose. Nasi pun ada glucose, right? From the rice. For example, one day you are having a picnic, okay? Beside the river bank, ada leftover. You have makan separuh je kan? Ada leftover. Then you throw in the water, right? This one. So this is you are having this rice, you throw in the water. So what's happening of this rice? Rice ni kan? This one is rice. So actually, in the water, we have these microorganisms, bacteria. Bacteria will decompose the rice, but in order of the bacteria to decompose, they require oxygen in the water. So if we pollute the water by throwing lots of the rubbish or food waste, for example, so that means we are making the bacteria active so much because they need to decompose, or the other terms is oxidize our this one organic matter. Organic means is from the natural source. But in order for them to decompose, they consume this oxygen. Faham tak? Itu dia punya analogy dia. So the analogy is like that. So that's why we cannot actually do some addition of the pollution, because we increase the amounts of the bacteria to decompose our waste, and then the oxygen become depleted, kurang, become reduced. Okay, in the lab, we can do some prediction because we can calculate the theoretical oxygen demand based from the substance. In here, for example, is glucose. So for example, if we measure the amounts of glucose is 108.75, so how much is the theoretical oxygen demand? We can calculate. So first, we need to have the equation. So this is the glucose. Okay. So this one is through the oxidation process from the bacteria. Will produce carbon dioxide and water. Betul lah, kalau ada banyak pencemaran, if there is a loss of pollution, they also increase the carbon in the environment. Carbon Okay, this is glucose oxidization or decompose by using by bacteria. Biasanya by bacteria. Okay, we produce carbon dioxide and water. So first, we need to calculate the molecular weight. You must refer to the periodic table. So glucose, 6 atom for carbon, 72. Macam mana dapat 72? Is 12 times 6. Yang ini 12 times 1. Yang ini pula 6 times, oksigen berapa? Oksigen. Nauliana, berapa oksigen? Saya okey lagi kan? Masih ada lagi bersiaran? Saya tekan seorang ni.
Okey. Oksigen 16.
Yes, 16 ya. Thank you Zidli. So 16 maknanya 6 times with 16 dapatlah 76. So total of the glucose of the molecular weight is 180. Alright. Oxygen kan ni 602. Tapi you must make sure that the equation, the reaction must be balanced. Kalau sini C6, this one also C6. Ingat lagi tak ni? Ingat. Tapi this is very simple. Hydrogen 12, this one must be 12. 6 times 2, 12. Oxygen dekat sini 6, sini ialah 12. So dekat sini 6 kali 2 apa? 12. Campur dengan 6, 18. So 18. So balance, must be balance input and output. So 6, kita tengok yang ni. So that means the oxidation. The 6 times 2 for oxygen is 16. So that's why you got 192. So you can calculate. This is given from the testing. So this is the 192 of oxygen oxidized to 180 gram of glucose to carbon dioxide and water. So the requirement of the demand is 116. 116 kita boleh kira theoretical. Ada teori lah. Eksperimen lain. Okay, so if the concentration of glucose is 10, what is the theoretical oxygen demand? Okay, you must know that in here, if 10, then 6 for the oxygen, 32 for the oxygen, and this is the molecular weight kan? So 10.7 milligram oxygen in 1 liter. Okay, yang ni pun sama, iaitu about the acetic acid. Acetic acid is one of the, what's the use of the acetic acid? For food? Banyak guna dia ni, saya lupa dah. Alright, so acetic acid also can be oxidized to produce carbon dioxide and water. First, you need to make sure that the reaction must be balanced. Carbon 1, 2. Carbon kat sini 2, betul ya? So hydrogen 3 campur 1, 4. So this one 4. 2 dengan 2, 4 kan? Lagi apa? 7 kan? Oxygen 2, 4, 6. 4, 6. Betul lah. So balance So given 250, so this is for the molecular weight of the oxygen and 60 gram per mole for the molecular weight for acetic acid. Acetic acid ni guna untuk apa Rasa masam kan? Byproduct of fermentation and gives vinegar its characteristic odor. Vinegar. Masam. Okay. Okay, that's the theoretical oxygen demand. I have given you one tutorial in author. You can try first and then next week we can discuss together. Boleh? By using this example. Senang je. Okay. Okay. By using the oxygen demand, masih lagi oxygen this is our main concern our oxygen demand in the water. So we can calculate the biochemical oxygen demand. Always oxygen demand. Berapa banyak oksigen yang diperlukan. Right? So this one, please you need to analyze or can differentiate between the BOD and COD. Another one is COD Kena faham betul-betul. Boleh. Okay, biochemical sini, man. You know that this is, the term is bio. Bio means what? Bio tu apa? Bio. Pernah belajar bio? Ke memang belajar engineering saja? Give me examples of bio. Living things lah living things. Jadi we use indicator or reference is microorganisms. Okay? Sama konsep dengan tadi. Right. Tadi you have leftover nasi kan? You have the leftover, you're having a picnic with your friends, your girlfriend or your boyfriend. Ada leftover. Then masa tu belum belajar lagi environment lah. You are not taking the environmental class yet. Then you just throw the leftover in the water. Because you said, okay, never mind, it can be decomposed, right, naturally. Tapi in the water system, then memang ada decompose kan. If the water is too much of the substance of organic matter, macam tadi rice, then they are inviting lots of microorganisms. Microorganisms will decompose or oxidize the organic matter. Organic matter ni tadi saya kata tadi rice lah. Rice. Okay. Then bila dia decompose, dia juga required oxygen in the water. That's why kita boleh kira lah, if the BOD is high, that means the oxygen level is low. Okay, faham Okay, so a week after, you come again. Tapi kali ni you macam-macam lah makan kan, bukan setakat rice, bukan setakat nasi lemak. Tapi mungkin you buat pizza, right? Pizza Hut kan? Pizza Hut ke Domino's sedap kan? Dah petang dah ni. So petang nak buka apa ni? So for example, kita nak beli pizza lah, Pizza Hut, right? Ada leftover. Leftover tu pun kita throw in the water. Ni air kita kan? Ni pizza. Ni awak lah ni. Buang kat sini. So apa jadi? Saya nak tanya lah. Orang lain pula to explain. So what's happening there? Zulfairi. Zulfairi Zarif ada? Ni dah pergi bazar lah ni. Siapa nak try? Salah tak apa. So what's happening? If you throw the leftover of your pizza, for example Devi ada? Devi? Devi?
Ada doktor.
Cari info. Okay? Lamanya Google. Ada nak, siapa lagi nak try? Explain. Bala ada? Bala?
Yes, doctor.
So what's happening? relate with the BOD. So my drawing there. What's happening when you throw, for example, in here your food waste in the water? Semua tak faham ke macam mana ni? Debbie dah?
Belum doktor, tak faham.
Tak faham lagi. Ashraf? Ashraf bin Osman? Tapi Bazar? Ahmad Hakim? Semua senyap ni? Chris?
Yes, doctor.
Apa yang you faham?
The bacteria will decompose on the food, then
Dia akan
carry out the oxidation process,
yes,
then will produce the carbon dioxide.
yes. Okay. So, for example you throw ni kan, tadi saya kata you makan pizza kan, tak habis. So this is your pizza. So ada bakteria dalam ni, bakteria in the water, dia akan decompose atau oxidize of your organic matter. Organic matter you punya pizza lah. Organic matter mana tadi? Ni. Organic matter you punya ialah pizza. Ni. Okay. So in order for the bacteria to decompose your pizza, it requires oxygen. Dia akan ambil oxygen in the water. Right. So kalau ada banyak sangat apa ni ya Allah hai. Ada banyak sangat pizza dalam ni, so bayangkanlah ada banyaklah you punya bakteria ni to do the process. Bakteria pun akan consume oxygen. Oxygen makin kurang. Supposedly the oxygen is used by the aquatic life. In this case, tak ada lah. Sebab dia guna pakai kan. Faham tak? Your organic matter is your food waste and this is the bacteria. Bacteria will decompose or oxidize your food waste, right? In order to do the process, it requires the oxygen in the water. So during the BOD test, we always measuring the dissolved oxygen in the water. Kita memang ada DO meter dalam lab. In the lab, we are having this DO device, DO meter device. Then we just put the probe in the water and test how much is the DO. Macam tu. So this is the testing, the testing that we usually conduct in the lab. Boleh faham? Boleh faham Devi? Bala? Ashraf? Boleh? Okay. Okay, this is actually the BOD bottle. Ini BOD bottle that we usually use it in the lab. Okay. Tak payah tahulah sebab biasa kita saja untuk lab ni. So this is the equation. We must measuring the initial DO and juga final DO and then we incubate for 5 days. 5 days, why? Because we want to measure the amount of the oxygen that be taken up by the bacteria or microorganisms. Okay. So this is the procedure. For example, day 1, 7.5. Masih banyak lagi kan DO dia. Ni DO after day 5, then it reduced to 5. So the difference is 2.5 2.5 kan. So the BOD is a 75 mg per liter. Dia pun ada dia punya indication dia. Kalau 75 is not really too much of the BOD. So biasanya kalau BOD for the highly contaminated water, it can go for 400 for example 400 mg per liter macam tu. Okay, lagi sikit in here, to know the process of the BOD, we usually know how much is the organic matter oxidized or decomposed, right? By bacteria yang bekerja. Bacteria will oxidize the organic matter. So in here, for example, 10 days ataupun sampai kat sini, the process of the days and also the concentration of organic matter is like this. Okay. So that means organic matter remaining, organic matter oxidized. So we are using the BOD reaction like this. So LT means the amount of oxygen demand left after time, and K is the BOD rate constant. Biasanya K, the reaction rates is actually influenced by the temperature, right? So the equation is like this, to know the ultimate carbonaceous organic demand. Okay, saya akan terangkanlah what does it mean by carbonaceous organic demand. So in here, if you can have a look on this graph, biasanya 5 days kat sini kan, 5 days. This is after 10 days, the decomposition process usually constant maknanya dia dah tak berlaku proses decomposition or oxidation yang ini sama. This is to explain about this one. Akhirnya kita akan dapat this one, the DO depletion of the first order to get the BOD at a certain time. L0 is the BOD ultimate kita panggil and this one K is the reaction rate and T is the time. I already put one question, if I'm not mistaken, in the tutorial. You can try first and then next week we can discuss. Okay, this is examples of the equation. If the BOD waste identified is 102 and BOD 20 after 20 days, the ultimate means the highest or the maximum BOD is 158. So what is the K base? So you can put in this equation and then you can calculate the K value, 0.21 per day. This is the reaction rate coefficient. Okay, so because we are dealing with the microorganisms, right, living things, so basically it also affected by the temperature and also the metabolisms. So temperature is very important in order to know the BOD rate reaction K value. Okay, so for example in here, the reaction rate for the theta for temperature between 4 to 20 is 1.135, but it is slightly lower if the temperature is more than 20 to 30 degrees Celsius. So you can have a look at the example in here. Okay, this is my final slide for today. Okay, previously I discussed about the BOD. BOD is what? Fatin Raina?
Biochemical oxygen demand.
Okay, when we talk about bio, it must be living things, benda hidup, right? Okay, now we are measuring the COD. Still, we are refer the oxygen demand as our main criteria or main measurement. Nak tahu berapa banyak oksigen dalam air sebab to know the quality of the water. Okay, in the water system, right, water system, we have organic. Give me examples of organic matter. Guang Seng Chua. Organic tu apa? Guang.
Yes, doctor.
Examples
Dok,
organic.
organic. Organic means yang itu tak ada
apa?
tak ada itu bahan kimia punya dalam. Bahan kimia.
Boleh jadilah. Natural
Natural.
For example,
For example, I think some sayur-sayuran yang tak ada organic ada.
sayur veggies lah, veggies.
Veggie.
Betul? Okay, tak semua dalam air is only organic, right? We also have the inorganic. Okay, give me examples of inorganic. Muhammad Alif Ashraf. Alif Ashraf.
Ya, doktor.
Give me examples of inorganic substance in the water.
Air.
Air.
Iron.
Iron. Ferrum. Boleh lah. Ferrum contoh. Okay, ferrum plus ataupun ferrum 4 plus. Okay, inorganic means besides the natural like veggie sayur. This is for example from the metals, heavy metals released from the industry, for example, maybe from the pipelines, something that cannot degrade easily. You cannot decompose by using the bacteria. Okay, so this one, do you think that the bacteria can decompose the ferrum or inorganic in the water? Boleh tak? Can the microorganisms or bacteria decompose the ferrum in the water? Jawapannya apa? Nur Auni. Boleh ke tak boleh? Nur Auni Nabiha.
Ya, saya doktor.
Bacteria ni boleh tak decompose ni metals ni, inorganic? Anyone who want to try? Tan Jinxiang.
Ya.
Boleh tak bacteria tu decompose metals? Metals, for example, here is ferrum as an inorganic.
Rasa
Tak boleh, doktor.
Tak boleh. Betul so
Ya.
tak boleh.
Tak boleh.
Tak boleh. So in this experiment, betul so tak boleh, cannot. Bacteria ni tak boleh decompose inorganic. So in this experiment, COD kita panggil, we need to use the other compound which is we use chemicals which is oxidizing agents. Biasanya kita akan guna potassium dichromate. Ni potassium dichromate. C2O7 kata silap saya, 7. Dia punya oksigen banyak sangat. Okay, potassium dichromate. You can Google lah dia punya compound structure dia. So this is a very strong oxidizing agent. In the lab, we will use this as a strong oxygen, chemical oxidant. We have the process heating and converting the organic matter to the sample heated into some excess of the dichromate, and then to know the levels of how much oxygen required is by using the ferrous ammonium sulfate, by using the different color. Jadi kita boleh dapat tahu lah how much the oxygen in terms of chemical oxygen demand. Okay, dia punya procedure in the lab is quite complex sebenarnya. Ada berapa proses. In the lab usually it takes about 1.5 to 2 hours to do the experiment of the COD. So but in this experiment, because we use the oxidizing agent,